So that's it. There are only stellar mass, intermediate, and supermassive black holes. Or are there super tiny black holes too? Well, the smallest black holes we have observed are all stellar mass black holes and bigger. But the general theory of relativity doesn't put a lower limit on how small black holes can be, only on how big stars must be to form them. If there's a different mechanism to form black holes, other than stellar collapse, it might be possible for tiny black holes to exist. Let's get the Schwarzschild equation out, but this time, instead of putting in huge masses like stars, let's see what happens if we try smaller masses, like Earth's. Earth weighs the equivalent of 3 micro solar masses, and it has a corresponding Schwarzschild radius of 9 micro kilometers, or 9 millimeters. That's about the size of a small ball. So imagine that in order to create a black hole with Earth itself, you'd need to devise a way to compact the entire planet into a tiny ball this size. I can't think of any gentle ways of doing that. What if, instead of calculating the Schwarzschild radius for a massive black hole, we use our own weight in the formula? I weigh about 75 kilograms, so if we calculate the Schwarzschild radius for a mass of 75 kilograms, my Schwarzschild radius would be 1 times 10 to the minus 25 meters. That's 10 million times smaller than the classical size of a proton in the nucleus of an atom. Tiny black holes aren't anything to worry about. First of all, we haven't actually ever seen a tiny black hole, and we don't know for sure if humans can create them. It may have been possible for small black holes, called primordial black holes, to have been created the moments after the Big Bang, but so far there is no conclusive evidence of their existence. Tiny black holes, because of their diminutive size, have a hard time eating. Imagine if you're a tiny 10 to the minus 25 meter sized black hole, and you need to try and eat a proton hamburger that would be the size of the sun compared to you. But there's an even more mysterious reason not to fear small black holes. They evaporate. Don't worry, we'll explain more when we begin to talk about quantum mechanics in a later section.